Hello everyone, good evening. So here we should start from question number 3 onwards. So here it is given that ABCD is a quadrilateral. ABCD is a quadrilateral in which P, Q, R, and S are the midpoints of the sides. So the sides AB, BC, BC. This will be C actually. If something is wrong, this will be C. Now here ABCD is a quadrant in which P, Q, R, and S are the midpoints of sides AB, BC, CD, and DA respectively. Then diagonal AC is the diagonal, AC is a diagonal, and we have to prove that first part is SR is parallel to AC and SR equals to half of AC. Second is PQ equal to SR, and third is PQRS is a parallelogram. So the proof will be, we say that in triangle DAC, we can say in triangle DAC, S and R are midpoints. S and R are midpoints of the sides DA and DC. DA and DC respectively. Since why it is given. That's why it is given. So therefore we can say that SR is parallel to okay, so here it means I can say that SR is parallel to AC and SR equals to half of AC. By using the midpoint theorem. Similarly, in triangle EAC, P and Q are midpoints. P and Q are midpoints of BA and BC respectively. BA and BC respectively. So therefore I can say that PQ is parallel to AC and PQ equals to half of AC by using the midpoint theorem. So both SR and PQ are equal to half of SC. So therefore, we can say that PQ equal to SR. PQ equal to SR. And also, things like both are equal to half of AC. And similarly, PQ is parallel to AC, which is also again parallel to SR. So therefore, I can say in quadrilateral PQRS, in quadrilateral PQRS, PQ is parallel to SR and PQ is equal to SR. So therefore, I can say that these opposite sides are parallel and equal also. So therefore, I can say that PQRS is a parallelogram. Since the opposite sides are parallel, since I can say since one pair of opposite sides are parallel and equal. So hence PQRS is a parallelogram. So hence proven. Then in question number 4 is told ABCD is a rhombus. ABCD is a rhombus and PQRS are the midpoints of the sides, so that the quadrilateral PQRS is a rectangle. So it is given that ABCD is a rhombus. So we can draw one rhombus with ABCD, PQ, R and S. So this is P, this is Q, this is R, this is S. So they are the midpoints of the sides. And then we have to prove that this PQRS is a rectangle. So what we can do, we can draw the diagonal AC. Diagonal AC we can draw. And diagonal BD also we can draw. So it is given that ABCD is a rhombus and PQ, R and S, PQ, R and S are the midpoints. PQ, R and S are the midpoints of the sides. The sides AD, BC, CD and DA respectively. So hence we have to prove that PQRS is a rectangle. PQRS is a rectangle. So the proof is like this, that triangle BAC P and Q are the midpoints. P and Q are the midpoints of the sides BA and BC respectively, since it is given. So therefore, I can say that PQ is parallel to AC and PQ equals to half of AC, since by using the midpoint theorem. by using the midpoint theorem. Similarly, in triangle DAC, R and S are the midpoints. R and S are the midpoints of the sides DC and DA, respectively. DC and DA, respectively, which is also given. So therefore, we can say that SR is parallel to AC and SR equals to half of AC. SR equals to half of AC. By using the midpoint theorem. Using the midpoint theorem. So hence we can say that in quadrilateral PQRS, SR is equal to PQ, which is equal to half of AC. And obviously SR is parallel to AC, which is parallel to PQ. That's why it is proved above. So hence one pair of opposite sides are equal and parallel. So it is a parallelogram. So therefore PQRS is a parallelogram since one pair of opposite sides are parallel and equal. So PQRS is a parallelogram. Also, you can say that AC is perpendicular to BD. AC is perpendicular to BD. Since why? Since in a rhombus, the diagonals bisect each other at right angles. Also, in triangle ABD, S, P and S are midpoints. P and S are the midpoints of the sides AB and AD, respectively. AB and AD respectively. So therefore, I can say that PS is equal to half of BD. PS equals to half of BD, and PS is parallel to BD. PS is parallel to BD. PS equals to half of BD. By using the midpoint theorem. Now, since PS is parallel to BD, PS is parallel to BD, and PS is parallel to BD and PQ is parallel to AC and PQ is parallel to AC, and obviously AC is perpendicular to BD. Since why we have proved them earlier, proved earlier or proved above, we can say proved above. So therefore, we can say that PS will be perpendicular to PQ. PS will be perpendicular to PQ. Therefore, I can say in parallelogram PQRS, one angle is a right angle. One angle is a right angle. That is angle SPQ. Angle SPQ. For here only I can say PS is perpendicular to PQ. It means angle SPQ that is equal to 90 degree. It means here one angle is a right angle. So hence we can say that. Hence obviously PQRS is a rectangle. PQRS is a rectangle. Since why if we can show that PQRS is a parallelogram where one angle is a right angle, then automatically we can prove that PQRS is a rectangle. So hence proved. And then here in question number 5, it is told that ABCD is a rectangle and PQ, R, and S are midpoints of the sides AB, BC, CD, and DA respectively. Show that the quadrilateral PQRS is a rhombus. Now here it is given that ABCD is a rectangle. ABCD is a rectangle and PQ, R, and S are midpoints. PQ, R, and S are midpoints of the sides AB, BC, CD, and DA respectively. Then we have to prove that PQRS is a rhombus. PQRS is a rhombus. That means that if it is given that ABCD is a rectangle and P, Q, R, and S are the midpoints of the sides A, B, B, C, C, D, and D, then we have to show that this PQRS should be a rhombus. Now here, how to prove it? Proof is, so now here also we can draw the diagonals, that is AC and BD. So in the previous one also we should have written the construction. The construction we should write. The construction we should have written that the diagonals are drawn. Diagonals AC and BD are drawn. This we should have written here. And here also, this one also, before writing the proof, we have to write the construction. Before writing the proof, we have to write the construction. Which is that the diagonals AC and BD are drawn in the rectangle ABCD. Then we will write the proof. In the proof, we will write that AC equal to BD. Since in a rectangle, the diagonals are equal. In a rectangle, the diagonals are equal. The diagonals are equal. Diagonals are equal. So now we can say that in triangle ABD, E and S are midpoints. E and S are midpoints of the sides AB and AD respectively. AB and AD respectively, since it is given. So therefore, we can say that PS equals, okay. Therefore, we can say that PS is parallel to BD and PS equals to half of BD, which is by using the midpoint theorem. By the midpoint theorem. Similarly, we can say in triangle CBD, Q and R. Q and R are the midpoints. Q and R are the midpoints of CB and CD respectively. CB and CD respectively, which is given. Is given. So therefore, we can say that QR is parallel to BD and QR equals to half of BD. So therefore, I can say that, and also, so therefore, I can say that in quadrilateral PQRS, therefore, in quadrilateral PQRS, PQ is equal to RS. PQ is equal to RS, since why both are, no, PS is equal to QR. Sorry, PS is equal to QR. PS is equal to QR, since why both are equal to half of BD. And also PS is parallel to QR, since both are parallel to BD. So therefore, I can say that PQRS is a parallelogram. Since one pair of opposite sides are parallel and equal. Since one pair of its opposite sides are parallel and equal. Parallel and equal. Parallel and equal. So let me equalness is a, this is again. From this will be so that PQ is equal to RS. Here PS is equal to QR. It is a parallelogram. And also in triangle ADC, triangle ADC, S and S and R are the midpoints. S and R are the midpoints of the sides DA and DC, DA and DC, respectively, since it is given. Since it is given, therefore I can say that RS is parallel to AC, and RS is equal to half of AC. So by using the midpoint theorem, also AC equals to PD, since ABCD is a rectangle. So I can say that RS is equal to half of PD also. Hence we can say that, and also RS is equal to PQ. Since the opposite sides of a parallelogram are equal, each side of a parallelogram are equal. So hence we can see that RS is equal to PD, half of PD. So half of PD is PS also, and QR also, and it is equal to PQ also. So RS is equal to PS is equal to QR is equal to PQ. So therefore we can see that in parallelogram PQRS, all the sides are equal. All the sides are equal. Hence we can say, hence PQRS is a rhombus. QRS is a rhombus. So hence proved. So I hope all of you understood till the question number 5. Still any doubts that you have, please write that in the comments. We shall obviously clarify them. So thank you everyone. Bye.